Hi guys, welcome back to the channel. So today we're going to be creating this kind of distortion RGB split effect you see when we scroll. Again, we're using kind of smooth scrolling to get this implemented. And we're also going to be using the Free.js library as well, because this is going to make use of shaders. I did try to find ways to kind of do this with vanilla JavaScript, but it was proven impossible and too memory intensive. So this is using shaders. It's quite a bit of code, I'm not going to lie, to implement this, so stick with me. But yeah, I hope you enjoyed the tutorial, guys, and yeah, let's get going. Thanks. Okay, guys, so to get started with this project, we're going to need to install some dependencies, okay? So we're going to be using, you're going to need to have Node.js installed on your machines. Basically, Node.js is just a JavaScript runtime. You can use it to build servers. In this case, we're going to be using it to install the Free.js package, which we're going to be used to create these kind of animations for this project. So Free.js, this is a JavaScript library used to create kind of really cool animations. You can do 3D graphics, that kind of stuff, 3D rendering with this library. It makes it allows you to have access to kind of WebGL and shaders as well, which we're going to be using for this project. If you check out their homepage here, Free.js, you'll see there's kind of loads of different projects on display which you can go and view. Some amazing websites and web applications created with this library. Okay, so just make sure you install Node.js, and then what we're going to do, we're going to just create a new project, which I've just called a RGB tutorial here. You can see there's nothing in there at the moment, and I'm just going to first open my terminal in VS Code. And in the terminal, we're just going to say first npm init -y, like so. That will just get a basic kind of a package.json file up and running, so no project up and running. And I'm just doing the -y there just to create the default options or the default settings when we load a project, okay? And then just for the one dependency we're going to need for this project is, as I said, Free.js. So we can just type in here npm free, like so. So that should be npm free. And that will install Free.js. So now you'll see, if we go to our package.json file, you'll see under our dependencies, free. Okay, that's our version there as well. Okay, so that's basically it for our installations. So the next thing I want to do here is just get the files that we're going to be using, or just like create some files, okay? So you'll notice here as well, as we've installed free, we get this kind of node modules folder up here with the free kind of files, or the dependency folder here. Okay, so let's just first create, we'll create an index.html file. We'll also create a style.css. And then we're also going to create an app.js. Okay, so let's just create actually what I'll do, I'll create a separate JavaScript folder. So we'll just say JS here for a folder. And in here, we're going to say app.js. And then I also want we're just going to have a shaders file in here, a folder in here as well. So we'll create a new folder, we'll call that shaders. And I'll explain what shaders are soon when we get to it, but we'll just leave it like that for now. I think that's pretty much it. All I want to do is just actually get some images. So I copied some images earlier. So let me just copy this folder over. Okay, so these are just some images I sourced earlier in a separate folder called images. I have 4 images we're going to be using. So these are just from unsplash.com. Just use any images you want, really. It doesn't really matter for this project. I've also just added I'll explain this later. This is what we're going to be using to set up our Free.js settings, okay? Okay, so let's get on with the code now. So if we go to our index.html file, we'll just get the usual boiler code up and running, just exclamation mark. I'll just, in the title, just say RGB. Okay, and then in the heading, we're just going to link to our app.js. So I'll just say link, and then we'll just say style.css, our style.css file. And then in the body, at the bottom, we'll just say script source, and then we're just going to say app.js. Actually, no, we need to go to ./js, and then /app.js, okay? And this ./ will just reference the current directory, which the index.html file is in. we'll go to the JS file folder and then just use this app.js file. Okay. Now coming in here into the body, we're just going to have a main element. Okay, we're going to be using kind of smooth scrolling to do this, so to achieve this effect. And then I'm going to have an inner div of a class of scrollable, which is the element, the div which we're going to translate just to get that kind of scroll effect. And then within here, we're going to have a div of a class of container just to house all of our images. And then I'm going to have another div of a class of image container, like so. And then in here, I'm just going to have first the H1, and we'll just use whatever word you want. I'm just going to say monochrome for now. And then also, we'll just say an image tag, and the source, I'm just going to reference the images folder. So we'll do ./images, and then just the first image, so 1.jpg. And then I'm just going to copy this image container div down. We want another 3 of these, as we've got 4 images we're going to be using. So we'll just do that now. 2, 3. For the second image, I'm just going to adjust the wording slightly here. So we'll just say street, make it all in capitals. And then change the 1 to 2, like so. And then the third image, we're just going to say abstract, and I'm going to change that to 3. And then the final image, I'm just going to say this is a picture of a rose, so I'll just say rose, and then image 4, like so. Okay guys, so that's it for our HTML. Okay, so nice and simple, not too much to do there. Let's move on to our CSS next. And actually let's open this in live server just so we can see our changes as we go as well. Okay, so now let's just bring this over here a bit. So in our style.css, let's get rid of these. First thing I'm going to do is adjust the global settings. So let me just get this, use a star symbol here. This will just affect the global settings for our CSS. I'm going to say margin 0, padding 0, and box sizing of border box. Okay, so now you can see all the default margins have been removed. And then kind of underneath this, I'm just going to select the body and HTML. Okay, and for this, I'm just going to set the overscroll behavior to none. You can see at the moment we get this kind of bounce occurring when we scroll to the top of the screen. I'm going to set the overscroll behavior to none, and that will stop that effect happening. Okay, as you can see now we don't get that kind of bounce anymore. Okay, and then the next thing I want to do here is just adjust the background color just to solid black. So we'll just say 0, 0, 0, like so. And then underneath this, I'm just going to give this a height of 100 viewport heights. And then we're also just going to give it a width of 100%. Okay, so that will just fill the viewport basically. Okay, so now underneath this, next we're going to select is the main element. And we're going to position this as fixed. Okay, this is going to be fixed. And then again, this is just going to take up, so the width will be 100% and the height will be 100 VH. Just to fill the screen. Okay, so now you see if we go to our dev tools here, and if we go to our the main element, which you can see it takes up the whole screen. Okay, so we're hovering that and it takes up the whole viewport. Okay, so now underneath this, next thing we want to do is we're going to select the scrollable div. And for this scrollable div, we're going to position this absolute relative to the main element. Say absolute, we'll say a width 100%. And we're going to give this, so it's from the top, we'll say 0, and the left 0, just to make it to the top left of the main element here. And then we'll also just say will change, and we're going to say transform. And this will just optimize the browser as we're going to be translating this on scroll. So we're just saying will change transform. This will just optimize the browser to perform those kind of transformations on this div. Okay, so kind of underneath this, next thing I want to select is the image container. So .image-container, like so. And then I'm going to say here, we're going to position these relative to each other. So they'll all appear underneath in the actual flow of the HTML. And then I'm going to give all these image containers a width of 100%. That will just fill the viewport horizontally. And then I'm going to give them all a height of 100 viewport heights. So that'll all fill the screen. So as we have 4 image containers, the combined height will be 400 height of the screen, basically. So 400 viewport heights. And then underneath this, I'm just going to set the overflow to hidden. And then that will just hide, it will stop any kind of overflowing of the images. And then I'm going to display this in Flexbox. So each of these image containers using Flexbox. And this will just allow us to center the images to the image container nice and easily. So I'm just going to say align item center and justify content center. Okay, so that you can see that slightly centered our images there. So now come underneath this, the next thing I want to do is we're going to select all of our H1 elements. Okay, so say H1, I want to position these all absolute relative to the image container div parents. Okay, so you'll notice, remember, in our image container divs, we all have a H1. They all have a H1 element, okay? So we're referencing the, we're positioning these relative to the image container that they're placed in. So we'll just say position absolute. I'm going to say left, of 0, say top, let's do left of 55%, sorry, left 55%, and we'll do a top of 60%, like so. And then underneath this, I'm going to say z index, I just want to bring this in front of the canvas, so just say z index of 5, and then I'm going to say color, just make this a white color for now, we'll just go for this azure color here. Okay, as you can see there's our font, H1, and then I'm just going to say, actually that will do for now. So next thing I want to do, so we're nearly there guys, so let's just select the image next, we'll say image, and I'm going to position this image absolute, and then we're going to say, I want to give it a height of 60%. Okay, and then we're also going to just say, actually we'll keep the visibility for now, we'll change that later, and I'll just say canvas. Okay, so we get with Free.js, it's going to add a canvas to the screen. Okay, so we're just going to just apply some CSS to this canvas. We're just going to say position fixed. I want to set the Z index to -1 just to bring it behind everything. And then say top 0, left 0, like so. And we'll adjust all the kind of width and heights of the canvas with our JavaScript. So that's pretty much it. I just want to get a better font actually. So I do have one downloaded on my machine called Harmon. So I'm just going to copy this over. Let me just open this up, this directory. Okay, so I have a file here. So OTF, an open type font. I downloaded this off, it's online, Harmon extra bold font, but use whatever font you want really. Okay, so let me just apply this now. So in our style.css, what we need to do here, if we go to the top, I'll just set the font up here. We'll just say at font face, like so. We're going to say font family. And I'm just going to say, we'll call this Harmon, like so. And then underneath this, I'm just going to say the source of this font. And then we'll say URL. I'm just going to point this to the URL of that file, which is this OTF file, okay? And then after this, we need to specify the type of the font. So I'm just going to come after this bracket and we'll just say format. And this is, as I said, an open type font. So we'll just say open type, like so. And then in this global settings, we'll just say font family. And I'm just going to say Harmon, like so. You can see now we've had that font applied to our text. Okay, so you'll notice we can't scroll yet, and that's because it's all fixed to the screen at the moment. We're going to be using JavaScript to apply this transformation for the smooth scroll, okay? So let's do that now. Let's come to our JavaScript. That's it for our HTML and CSS, by the way. Yeah, So let's just go to our JavaScript now. So in our JS folder, into app.js. And the first thing we want to do here, is I'm just going to say, let's get the smooth scrolling up and running, okay? So to do that, I'm just going to say const, and I want to select that scrollable div, okay? So say scrollable equals, and we're going to say document dot query selector, and here we'll just say dot scrollable, okay? And then so we just need to get some variables up and running to get this smooth scrolling working. So the first one we're going to be using is the current variable. So say let current equals 0. Then there needs to be a target variable as well. Target equals 0. And I'm going to set an ease. So say let ease equal 0.075, like so. Okay, and then underneath this, next we're going to be implemented is a linear interpolation function, okay, and this is going to allow us to just have this smooth scrolling effect, okay, so we're using linear interpolation just to get a nice smooth animation, okay, so function, say lerp, and let me just comment this actually just so you can follow along. We'll just say linear interpolation. So this is used for smooth scrolling, and we're also going to be applying like an offset setting using this linear interpolation function. So I'll just say and image offset uniform. Okay, so we're going to be changing a uniform, which is a shader kind of tool that we're going to be passing back to our shader programs. Okay. So I'll just say that. So uniform image offset uniform adjustment. Okay, so in the lerp function, this takes in a start position, an end position, and a t. We're just going to say an ease variable, but I'll just say t for now, for time. And then here we'll just say return start. The equation for this is times 1 minus t, and then we're going to add end times t. Okay, so what this does, I've explained this in previous videos, but just for clarity, I'll explain now. This will take in a start position. So if I just show you an example, if we say we wanted to start from 10, and then we wanted to end at 20, and then this easing, if we wanted to get 50% between 10 and 20, which is obviously 15. Okay, so halfway between 10 and 20. So for a half, we'd say 0.5. If we just put the lerp function in here. So what you should see now is 15 logged to the terminal, which is halfway between 10 and 20. Okay, so if we do that now, go to the console, you can see we have 15. Okay, so halfway between 100 and 200 is obviously 150, and that's logged to the terminal there like so. Okay, you can do 20% increments, so 0.2, you get 120. So that's what that lerp function is doing, and we're going to be using this to create this smooth scrolling effect. So now underneath this, we're next going to create an init function. Okay, so function init, and this is just used to basically, at the moment we can't scroll. Okay, we don't have any kind of scroll bar on our screen. So to change that, we need to just set the body height. Okay, so we're going to say document dot body dot style dot height, and that's going to equal. We'll do backticks here, template literal, and we're going to say that scrollable div we have, and then we're going to use a get bounding client rect, which gets us the dimensions of this element, and then we're just going to say height, and then after pixels. Okay, so now you'll see if we call this init function, you'll see now we get that scroll bar appear. Okay, and the height of the document is now the same as the scrollable div. Okay, so next thing we want to do here is we want to get a smooth scroll function working. Okay, so we just say function smooth scroll like so. And then here, we're just going to simply set, first thing we want to do is set this target, okay? So this is where we want to scroll to. And we want to make that equal to obviously the scroll right position where we scroll on the page, okay? That's got to be the final target. So here we'll just say target equals window dot scroll y, and that will get our current scroll position. And then after this, we want to set the current variable, okay, using this target. So we'll say current equals, and here we're going to use the lerp function. We're going to pass in the current, which we initially set at 0, and then we're going to say we're going to pass in that target, which we've just created, so that's the scroll y position, and then we're going to just pass in our ease variable, okay, so say ease here, and that will get the kind of, remember I showed you this lerp, it gets the kind of percentage between the current and the target position. And then what we want to do is we want to set that scrollable div, we want to transform that, so say scrollable dot style dot transform, and here we're just going to say equals backticks, we're going to say translate 3D. Okay, so this translate 3D, make sure you use backticks, translate 3D. The first parameter is the x-axis, which you want to keep at 0. The second is the y-axis, so that's the scroll position, so we'll just do a template literal here. We're going to say minus current, and here we just say pixels, and then 0. Okay, so now, I think, yeah, we just got to close off this backtick, like so. And then what we want to do here is, for now, let's just do a request animation frame, because we want to call this smooth scroll over and over again, okay? So we're going to basically say smooth scroll in here, and then if we call this smooth scroll after the init function, say smooth scroll, you should see we can now scroll the page, which we can. Okay, and then obviously if you adjust the ease on here, if you do it, we can do it really slow now. You can see that's just going ridiculously slow. So I find, let's do 0.01. Yeah, you can see that's the lerp in action. Okay, the linear interpolation. So it's interpolating between the current position and the target scroll y position, and then you get that nice smooth scroll effect. I'm going to keep it at 0.075. I tend to find that's a nice kind of speed for desktop applications. Okay, that's it. So let's move on to the actual, that's the smooth scrolling done. Now we want to implement some free.js, okay? So what I'm going to do actually is close this down, because what we're going to be using for this, this is another tool you're going to need to have installed. Okay, so it's called Parcel Bundler, or just do Parcel.js. And just install this globally. There's a kind of command here. I think, yeah, if you just follow this getting started, if you just do an npm install, I've already got this installed, so I'm not going to do it. Run this in your terminal. I've installed it globally, so I can access it anywhere with this global flag. Just do npm install g parcel bundler, and that will install this. And this will basically just compile all of our free.js code and allow us to use it directly in the browser, okay? So let's just, as I said, I've already got that installed. So now what I'm going to do at the top of my JavaScript file here is I'm just going to say import, we're going to import free.js, okay? So I'll say import all as free from free, like so. Remember we installed free.js earlier, and this will just import that kind of free.js library, okay? So what we want to do now is, below this smooth scroll function, we're going to create a class, okay? This is going to be our effect class, so we'll say class, and then I'm just going to say effect canvas, like so. Okay, first let's get a constructor up and running. So what this is going to do, this is going to be the kind of class where we're going to set up like our free.js settings, okay? We're going to set up all of our cameras, our kind of renderer settings, get all of our images that we're going to be using to apply the effect to, that kind of thing. And we're also going to be using it to create some mesh or some like meshes out of our images, which we can apply these kind of free.js effects on. So in our constructor, the first thing we want to do here is we're going to say this.container. I'm just going to set that to document.query selector, and we're going to just set that main element, okay? And the reason we're setting this is because we're going to append a canvas to this container, okay? So we're going to append the canvas to the main element. Okay, and then after this, we're going to get all of our images, which we're going to be applying the effect on. So I'm just going to say list.images equals an array, and then add the spread operator in there, and then we'll just say document.query selector all, and here we're just going to select all of our image elements, like so. And then I'm going to set an empty array next, saying mesh items, and that's just going to equal an empty array for now. Okay, and then I'll just add a comment here. This is going to be used to store all meshes we will be creating. Okay, let's just change the. Okay, cool. And then let me just bring this out a bit. So we also need, we're going to create some methods next, okay? So I'm just going to just call these now, but we'll create these in a minute. Setup, we first want to set up the camera, okay? So say this.setUpCamera, this is going to be a method we're going to implement. And then we're going to say this.create mesh items. This will create mesh items out of all of our images. And then we're also just going to say this.render. And this is what's going to be calling the animation over and over again. And that's it for our effect canvas constructor. Okay, so underneath this, the first thing I'm going to do is create an actual getter function. Say get viewport. And this is going to be used to get our kind of viewport settings. Okay, so for example, I'm just going to say let width equal window.innerWidth. That'll get the inner width of our current viewport. I'm going to say let height equal window.innerHeight. And then we're going to create an aspect ratio. So that would just be our, so that would, the calculation for that. So let aspect, and that's going to equal the width divided by the height. Okay, and then we're just going to then return an object of these. Okay, so we'll just say return an object, say that we want to return the width, the height, and the aspect ratio, like so. Okay, so this get keyword, this is just going to be like a kind of helper function which we can use. We're going to call the say if we want to resize the window, it will just reset the dimensions, and we'll be able to get the current width and height and aspect ratio using this getter function here. Okay, so next function we're going to implement, remember we created this in the constructor, this setup camera, so let's do that now. So underneath this we'll say setup camera. Okay, and the first thing I want to do in this function is we're just going to add an event listener to the window. So add event listener, going to listen up for a resize, and then in here we're going to say list.onWindow resize. And then we're just going to say .bind this. Okay. Just so we're going to create this function in a minute as well, this onWindow resize. This is just going to be, it's just going to add an event listener to the window, listen up for any resize events, and then this onWindow resize will basically just recalculate the dimensions of the camera, just so it never goes out of sync with the viewport, okay? And we're just binding this keyword so we can call on this instance when we're in the production environment, okay? So underneath this, first thing we're going to do is create a scene, okay? So we're just going to say this.scene equals new free. So we're using that free library we imported above, and then we're just creating a scene from that library, okay? Like so. That should be a capital S. Okay, so that creates a new scene, a free.js scene. And then we're going to next create a camera. We're going to be using a perspective camera for this, okay? And then here we're simply going to say, first thing we want to do is just create a perspective, okay? So the perspective, and this is kind of like the distance on the z-axis, so the distance of our camera from the screen on the z-axis, okay? So say let perspective equal, I'm just going to set this to 1000. And then, so the next thing we want to do is create a field of view. Okay, so say const FOV, and this is quite mathematical, okay? So we're just going to say here, I'll explain this after, I'll try and explain it after. So we're just doing 180 times, and then we're going to say 2 times math.atan, and then we're just going to say window, taking the window.innerHeight, and then we're going to divide that by 2, and then divide that by the perspective, which we just created here. And then we're just going to divide this by math.pi. Okay, so just to show you, this is as I said, this is very mathematical. Okay, so this atan function gets kind of the well, just to explain, there's an image here which I've included in this project basically. So this is the kind of perspective here, this red arrow. So this the plane is our screen. This is the distance. There's the camera. So this perspective was 1000. You'll see we've got two kind of right angles here. So 90 degrees and 90 degrees, which equals 180. And this is just what that kind of equation's working out. You can see we have kind of two angles for our field of view here. So that's why we're doing this kind of 2 times the window.innerHeight. We're dividing it by 2 because, as you can see in this image, there's 2 kind of sections to the plane. But that's just what this kind of function is doing. It's just setting up our camera so we can basically just input the correct coordinates when we're converting our images to these mesh items in Three.js. Okay, so it's like adding these items to a 3D space. Okay, so that's our field of view. The next thing we want to do here underneath this is we're going to set the camera. So we can set up a new camera. So I'm going to say it's this.camera equals new free.perspective camera, like so. And this takes in first the field of view, which we just created. So I'm just going to place the FOV in there, like so. And then it takes in the aspect ratio. So remember we created that in this getter function up here. So that should be FOV. So we're going to say here this.viewport, okay, which will access that function, and then we just want to access the aspect ratio here. So I'm just going to say dot aspect ratio, like so. And then the first thing, the near number, we're just going to set it to 1, and then the far number is 1000. Okay, so that's just the kind of perspective. Items that are close to 1 will appear closer, and items that are 1000 will appear further away. So that's our camera setup. Next thing we want to do underneath this is we're just going to set the camera position. So say this.camera dot position, and then we're just going to say dot set. And here I'm just going to say first on the x-axis 0, on the y-axis 0, and the z-axis we're just going to apply that perspective. Okay, so that'll be 1000 on the z-axis. Okay. And then that's it for our camera. So the next thing we want to do is just create our renderer, which is basically the canvas, which we're going to be adding to our project. So we just say here this.renderer equals new, we're just going to say free. And for now, I'm just going to use the WebGL1 renderer. Okay, and I'm using this because it works on mobile devices still. There has been an upgrade recently where you can just use the WebGL renderer, but I'll just use this one for now, for this tutorial, okay? And then I'm just going to pass some options in here. The first one is anti-alias, which is set that to true, and that will just kind of smooth out all the edges of our kind of meshes which we're going to create. And then alpha, I'm just going to set that to true, okay? And that will just make our background 0. See-through, sorry. We set the alpha, so the background of the canvas will be see-through. Okay, and then after this, I'm just going to set the size of the renderer. So say list.renderer.setSize, like so. And we're just going to, first thing it takes in is the width. So again, we're going to use our kind of getter function up here, the viewport. So we just say this.viewport .width, and then it takes in the height, so we'll say this.viewport.height, and then I think that's it. We'll leave it like that for now. And then we also, it's very important you do this, so we say this.renderer, and then we're going to say .set pixel ratio. And here we're just going to say window dot device pixel ratio. So this is very important, especially if you're using kind of a retina display. This will just set the pixel ratio, and so otherwise if you don't set this, your kind of message will look, meshes that we create will look kind of blurry and not very sharp. So this will just adjust that to be the correct pixel ratio. Okay, and then that's it for our renderer. Now all we need to do is just append this to our container, which we set up here. Okay, so this container section here, which is the main element. So we'll just say this.container.append child. And here it's going to append this.renderer. Okay, and then .dom element. Okay, DOM element like so. And that will basically just append the canvas to our window. So that's it for our setup camera function. Underneath this, I'm just going to create that on window resize function that we created here. This on window resize, so we'll do that now. On window resize, and in this function, I'm just going to call the init function up here. And you'll remember this init function just adjusts the body height if you have to make any adjustments there. And then underneath this, I'm just going to say this.camera.aspect. So for the aspect ratio, I'm just going to use this.viewport.aspect. I'll get the current aspect ratio. And then we're going to say this.camera. And there's a method called update projection matrix. And this function is just a included function in Three.js, which is used to recalculate the project dimensions so it fits as it should on our screens, all the meshes we create. And then underneath this, we're just going to change the size of the renderer as well. So say this.renderer.set size. And again, we're just going to say this.viewport.width and this.viewport.height, like so. Okay, so if we call, we'll call this, so we'll just say, if we come out here, we'll just say new effect canvas, sorry. And now if we come to, what we're going to do, let's just open it. So remember with parcel.js, what you have to do here is I'm just going to say parcel, and we'll just say index.html. Okay, and this will spin up a server. It's just currently building our app. Okay, so that's all built now. And now you can see, if we go to our dev tools, there should be a canvas. You can see the canvas has been placed on our screen now. This is the Three.js canvas, okay? Seems to be getting an error there. Let's see what that is. Okay, yeah, well, obviously we didn't create these functions yet, so this create mesh items and render, so we'll be creating those now. Okay, so after this, let's just create that mesh items now actually. So create mesh items, and what we need to do here is we actually need to create a new class, okay? So I'm going to come below this. We're just going to say class mesh item. Okay, and in the constructor for this class, we're just going to, it's going to take in the initial element, which is going to be the image we pass in, and it's also going to take in the scene, okay, because we're going to be appending this mesh item to the scene which we create up here, okay, and then in this constructor, we're just going to say this.element equals element. And then we're going to say this.scene equals the scene we pass in. Okay, and then we're just going to create an offset variable. So say this.offset, this is the kind of position that our message meshes will be on the screen. So we'll just say this to offset equal. So for the specific mesh we're creating for this instance, we're just going to use a new free vector 2, okay? And what this does, this will just take in two options, the X and the Y axis. I'll initially set those to 0. Okay, so we're using the free vectors here to implement this offset coordinates. And then underneath this, I'm going to say this dot sizes. This will be the size of the mesh. And again, that's going to be a vector 2 as well, 0, 0 initially. Okay, and then we're just going to say, we're going to call a function, a method here, this dot create mesh, we'll call it. Okay, so let's do that now. So first thing we want to do is actually I want to create a function called get dimensions, okay, and this will get the dimensions of each of the elements we pass into this mesh item. So I'm just going to say get dimensions like so, and the first thing we're going to do is just we're going to say const width, height, top, and left. So obviously these we want to get this. We're using the get bounding client rect. So I'm going to say this dot element dot get bounding client rect like so. And we're using destructuring here. This will pull the width and height and left and right, left and top positions for the element we pass in to this class. Okay. Underneath this, I'm just going to say this dot sizes. So that'll be this vector 2 here. This dot sizes dot set. And we're going to set this to the width. So the X will be the width here, and the Y will be the height. That will be the sizes. And then we need to set the offset next. Offset.set. And here, so the X number. Now this is, we're going to just need to do a slight bit of maths here. So we're just going to say, we're going to take the left, okay? And then, which we get in here in this destructuring, this left section. And then we're going to say minus window dot inner height divided by 2. Okay, and then on top of this, we need to plus the width of the element divided by 2. And the reason we're doing this is because Three.js, the 0, 0 coordinates start at the center of the screen. Whereas with our usual actual, HTML file, 0, 0 is at the top left. So we're just applying this, we're subtracting the, that should be inner width, sorry, not inner height. Yeah, so we're just subtracting the window.inner width divided by 2, which is half of the viewport. And then we're just adding half of the image width as well, or the element width, okay? So that's what that's doing. We need to do the same for the Y axis as well. So I'm just going to say minus top plus window dot inner height, and then we're just going to say divided by 2, and then minus height divided by 2, like so. Okay, so that's it for our get dimensions. Now what we want to do here is just create this create mesh function. So say create mesh, and then what this is going to do, the first we need to do when we create a mesh is we need to just create a geometry. Okay, so we're just going to say this dot geometry equals new free dot, we're going to be using a plain buffer geometry for this, okay? And just for the width, just put 1, height 1. We're going to be setting these later, so it doesn't matter for now. And then the segments, you can put whatever you want here, really. I'm just going to put 30 for now. 30. I'll show you what those do in a second. And then we next, with this geometry, so I'll just show you what a plain buffer geometry is. With Three.js, it's simply just like a plane like this, okay? So we're going to be using this plane. We're going to be adding our images to this plane, okay? So if we come here to do that, to load our image, we need to say this dot image texture. And here we're going to say that's equal to a new free dot image free dot texture loader. Okay, and then this has a method called load, and then to load the image, we're just going to say this dot element, which we pass in. So we're going to be passing the image using this element up here, and then we're just going to use the source attribute. Okay, like so, and then I think we're nearly. So what we want to do here as well is I'm just going to say this dot material equals new free dot. I'm going to be using a shader material here. Okay, and then so what this shader material will do, so first thing this shader material takes in uniforms, okay? Okay, and this is going to be an object which I'll create above this actually, this dot uniforms. Let's create that now actually. So I'm just going to say, we'll come above this material for a second. I'm just going to say this dot uniforms equals, that's going to equal an object. And the first one is, the first uniform we're going to use is the U texture, like so. Okay, and then this will be an object, we'll say the value of this, and that's going to be this dot image texture, which we just created above here. Okay, and then the U offset, and here the U offset, say the value, that's going to be a new free dot vector 2, and here I'll just set that as 0.0 for the X and Y for now. This offset is what we're going to be using to create that kind of distortion on our images using shaders. And then we'll do a U alpha. This will be used for like kind of opacity settings. I'll set that initially to 1.0. Okay, that'll just make it all the meshes viewable, not opacity at all, not opaque at all. Sorry. And then we'll just do. That's it for now. That's all we need. Okay, so now, so we've got our uniforms in our material section here. Underneath uniforms, we're just going to say vertex shader, and here let's just create these shaders now. So to do that, if you come to our shaders folder here, let's create a new file called vertex shader. .glsl, and then I'm also going to create another one called a oh sorry, my mind's gone blank. It is called a fragment shader, so let's do that now. I'll explain these shortly, guys. Okay, these get quite complicated shaders, so bear with me a second. Okay, so we need to import these as well. So at the top here, I'm just going to say import vertex shader from, and here we just say ./shaders /vertex shader.glsl. And I'm just going to do the same thing for our fragment shader as well. Change that to fragment. Okay, now if we come back down to our kind of material section, so the vertex shader will be the vertex shader we imported, and the fragment shader, that will be the fragment shader we imported as well. Yeah, that's it for now. Okay, so that's it for our material. Next thing we want to do after this is create an actual mesh. So this .mesh equals new free dot mesh, like so. And this will take in first the geometry we created up here. So just say this.geometry. And then it takes in the material. So this.material, like so. Okay, and now what we want to do is actually get the dimensions. So we just go and say this.getDimensions. I'm going to call that function, which will just get the current dimensions of the element we're working with, or the image we're working with. And then we want to adjust the mesh then. So we're going to say this.mesh equals, and here we're going to say, this.mesh.position.set. And here we're just going to say this dot, for the x-axis, we'll say offset dot x, and this dot offset dot y for the y-axis, and then for the z-axis we'll just say 0. Okay, so we want to do the same thing for our sizes as well. So this dot mesh dot scale here dot set, and here we're just going to say this dot sizes, and then change our offset to sizes as well. Okay, and then so the final function for this class is we're just going to say render, and again, so this is going to be repeatedly called, this function. Okay, and so what we're going to do here, obviously because we're going to be changing the position of these messages as we scroll, we need to get the dimension each time. So we're just going to call that getDimensions function just to set the position and the offset and the sizes. Okay, and then we're going to say again, we'll just copy this down actually, as we're going to be just recalling this each time for our render. And then what I want to do here as well is we're just going to change the uniforms as well. So I'm just going to say this dot uniforms dot uoffset we want to change here, and dot value dot set. Okay, and then we're just going to say this dot offset x. Actually, I'll just say 0, 0 here because it's not going to change anything on the x-axis. Okay, but we will on the y-axis. Okay, and here we're just going to say minus target, which we created our alert function, and then minus current, and then I'm just going to times this by a very small number because I'll show you why shortly. Okay, so that's it for our render, and that's it for that class as well. So now what we want to do, we want to come back up to our initial effect canvas class, and in our create mesh items, what we want to do is we want to loop through all of our images. So in this images array here, so to do that we'll just say for, we'll just say, we'll do a for each. Say this dot images dot for each, and for each image we're going to say here we're going to create a new instance of that mesh item class. We'll say let mesh item equals new mesh item. Okay, and that first takes an element. So here we're just going to pass in the image. Okay, so the image we pass in with this for each loop, and then we're also going to pass in the scene. Okay, so just say this dot scene, like so. And then we want to, once this instance has been created, we want to push this to the array, the mesh items empty array. We said here, use to store all meshes we will be creating. So I'm just going to say this dot mesh items dot push, and we're going to just push the mesh item we create, like so. Okay, and then that's it for the initial create mesh function. Now we just need to call this render function. Okay, so I'll just say render here. Okay, now the first thing I want to do here actually is just call a smooth scroll render. Okay, and what I'm going to do with a smooth scroll is I'm going to take out that request animation frame, just because we were recording this using the actual class renderer now. Okay, so don't need to call that out repeatedly, otherwise we'll have 2 request animation frames running. So we call that in here. And then after this, we're just going to loop through. So we're going to loop through all of our mesh items. So let I equal 0, whilst I is less than the mesh items dot length. I'm going to say I plus plus. That will loop through our mesh items. And then here we're just going to say this dot mesh items I, and then we're going to call the render function like so. Okay, so remember in our mesh items we had this render, and that will just basically, you know, position the meshes and update this uniform we're going to be using with our shader programs. Okay, so that's pretty much it. So for let's bring that there. Why has that gone down? Okay, so that's cool. And then finally, we just need to say, we need to actually just call the renderer, this dot renderer dot render, and then we're going to say this dot scene, and then this dot camera. It's passing the camera we created as well. Okay, and then we just need to repeatedly call this render function. So I'm just going to say request animation frame, and then we're just going to say this dot render, and then we need to bind this keyword. Okay, so let's take that out now. And let's see, let's just open this back up. Okay, let's then adjust the shade. Let's just create the shaders now as well. So if we come to our vertex shader. Okay, so basically shaders, they're comprised of two programs. Okay, we have the first one, which is a vertex shader, and the second one, which is a fragment shader. The vertex shader is used to kind of apply all the kind of vertices of our meshes or objects to the 3D canvas. Okay, and the fragment shader is used to kind of apply the correct colouring to each of the pixels within these vertices. Okay, and this shaders are very powerful. They use the kind of GPU to you know, create the kind of graphics on the screen. So it's it makes the browser more performant, basically. Okay, so in the vertex shader, this takes in, we pass in uniforms, okay, which we set here. Down below, you'll see we have that, you remember that uniform object we create here, and this is what we're passing in the material. So we pass in these uniforms, which has a texture, an offset, and an alpha. Okay, so in our kind of, let me go to the vertex shader first actually. So in our vertex shader, the first thing we want to do is just you know, add those uniforms in. So we say uniform here, and the first uniform is the U texture we pass in, and that's in a sampler 2D format. I'll just say U texture here like so. And it's very important to add a semicolon. So this kind of GLSL shader language is in kind of like a C syntax. And then the next uniform is the U offset, and that's in a vec2. And then U offset. Okay, so we're just initializing the variables up here, uniforms. And then we're also going to have a varying vec2. And that's just going to be a VUV. Okay, so this UV, this is kind of like, this just, this is a varying kind of variable, okay, and it's used to map the coordinates in our 3D space. And then I'm just going to say, we're just going to use going to set a pi variable, so let's just say m underscore pi, that's going to equal, from what I remember is 3.14 1529, something like that. We'll just leave it there for now. Okay, and then we're going to create a function here. So this function is going to return a vec3. So say vec3, and I'm just going to call this deformation curve. So this will distort our images when we scroll, basically. And this is going to take in 3 arguments. It's going to take in the vec3 here, taking the vec3 first, and this is going to be the position. It's going to take in then a vec2, and that's going to be the UV. Okay, and then it's going to take in another vec2 and offset. Okay, and then what this function will do, so it take the position that we pass in, dot x, and it's going to say equals position dot x plus, and then we're going to use some maths here, sin, so the sine function, uv dot y times that pi we set at the top here, the float, and then we're just going to then times that by offset dot x. Okay guys, I'm not going to explain this in this video because I'm running out of time, it's getting longer as it is, but this is just the kind of mathematical function we use to calculate these distortion effects for our images. Do the same thing for the y-axis as well, and that should be uv.x times math.pi, and then that should be offset.y, and then we just want to simply return the position, like so. Okay, and then every single shader program needs to run, it needs a void main function. This is the main function used to run the shader. And here, the first thing I'm going to do is just set the VUV variable that we initialize up here. That's going to equal the UV. Okay, and then we're just next going to say we're going to create a vec3, and we're going to call this new position, and that's going to equal, we're going to use that deformation curve function. We're going to pass in the initial position that's passed in via 3JS, taking the UV, and then also we're just taking that U offset as well. Okay, and then finally, to get this working, we'll say GL position equals projection matrix times model view matrix times vec4. We're going to pass in a new position 1.0, like so. Okay, so this is just kind of like the this is how we set our positions for each of our meshes on our, I can't say meshes. This is how you set it on the screen. Okay, so that's our vertex shader. Let's just do the fragment shader now. So if we come into our fragment shader, and then okay, so in our fragment shader, I'm just going to say uniform. Again, we're taking the sampler 2D, the U texture, which is the image we pass in. Remember the image textures. So we take our images in our app.js and we map them to 3JS textures, okay, using this texture loader here. And that's what we're passing in as a uniform. Okay, you'll see in our uniform, the texture is the image texture, okay? So in the fragment shader, that's what we're passing in there. Uniform float U alpha, just get that initialized, and then same thing for the offset, vec2 U offset, and then also we'll just say varying vec2 VUV. Okay, and that's why we set the vec2 VUV here. Okay, we're basically 3JS passes in the UV, and we use this UV just to map the coordinates for our fragment shader, okay? And then we're passing this variant VUV via the main function of our vertex shader. This will pass this VUV to our fragment shader, and then we can use it in the fragment shader program. So let's create a function which will be used to create the kind of RGB shift, okay? So we're going to say vec3 RGB shift, like so. And this will take in a sampler 2D, which will be our texture image. And then the vec2 UV, this will be a UV we pass in. And then also the final argument or parameter will be the offset. So we'll say vec2 offset, like so. And then what we're going to say here, so for the red channel, we're going to say float R equals, and we're going to use a texture 2D function, so texture 2D, like so. And that should be a capital D. And then this will take in the texture image, and then we'll just say, so the second argument will be the UV plus the offset. Okay, so we want to offset the red channel. And then for the green and blue channel, so say vec2 GB, that's going to equal texture 2D again. And again, we're just taking the texture image, and this time we won't apply the offset, we'll just say UV, like so. And what I did forget to add is we just need to segregate the channels here. So what we can do is we can just say for the red channel, we'll just say .r to get the red channel, and for the green and blue, we'll just say .gb. And then we want to return a vec3 combining these, so we just say return vec3 RGB. Okay, so now we're just going to say void main. Remember I said we always need a void main function in our shader programs. And then here I'm just going to say vec3 color equals, we're going to use the RGB shift function we just used. We're going to pass in the U texture, so the texture, the image we pass in via Free.js, and then we're going to use the varying UV we pass in via our vertex shader, and then finally we just want to apply get the offset as well, which we pass in via Free.js. And then we just set the GL frag color, which is the main variable for our main function in our fragment shader. We're going to set it to a vec4, and then we'll just simply say color, and then we'll just take in the U alpha for now, which will be 1. That's passed in via the Free.js as well. So let's try running this now. Let's see what's going on here. Right. Okay, so what I also want to do here is I'm just going to remove our images. So to do that, go to our CSS. I'm just going to say display hidden, because we don't want to see the actual HTML images. Okay, so it looks like these are now appearing within our canvas. Okay, so if we, for example, if we just remove the canvas, okay, that should be visibility hidden, sorry. Okay, so we can't see our images anymore. Now, we're not seeing them. What we need to do is in our app.js, so we're initializing the canvas up here, the effect canvas. This will, we do the render function. In our render function, we're saying render here. Okay, so why are we not seeing that? Just want to test something, so Okay, bear with me a sec, guys. Okay, right, it's going to take, let's see what's going on. What I don't think we're doing actually, we didn't add it to the scene, did we? Okay, we need to do that. We need to add this mesh. We say this.scene.add the mesh. Okay. Now we're getting an error, so let's see what's going on there. Okay, it looks to be an issue with our shader program. Looks like we've labelled float wrong, so let's just do that. That should be float. Okay, and there you go. You can now see we're getting that nice RGB split effect and that image distortion. Okay. Okay, so it looks like when we resize the screen, it's going a bit out of whack. So let's see what's going on there as well. On window resize. Sorry guys, the first time I'm kind of seeing these errors really. So let's see on window resize. Calling the init. Okay, so it's not liking our texture for some reason. Let me try this. Nope. should be aspect ratio. Maybe that's why. Okay, yeah, that's where the issue was. Okay, cool. So yeah, change that to aspect ratio. Okay, so there you go, guys. There's our effect. It's now working. So you get that nice, cool RGB effect. Okay, so obviously, you know, there's a lot of code to implement to get this kind of effect. I did try to find a way to implement this with vanilla JavaScript, but it was proven impossible, and it was using a lot of kind of memory to do it. So that's why I had to kind of just go down the shader route in the end. Obviously, I did kind of fly through the shader aspect of this, so I will try to, you know, go over this in future videos. It's still something I'm kind of learning at the moment as well, just to kind of, I really find this stuff really interesting. So obviously there's quite a fair bit of maths, and my maths isn't great, so you have to bear with me on that part. But yeah, I'm going to be using kind of shaders a lot more in future videos. But yeah, I hope you enjoyed that one, guys. Thanks for sticking around, and yeah, I'll see you in the next tutorial. Cheers.